All right, let's have a look at this now. Okay, so the graph on the right-hand side is a description of the temperature in a room over a period of 6 hours. Okay, so if I was just looking at it and telling a story at the start, it's around about 22 degrees. The temperature then declines after 2 hours to around about 18 degrees. It then begins going up again. Okay. You'll notice that it can be described by a quadratic function. All right, so let's answer some questions. What's the initial room temperature? Well, if we look at this point over here, it's sitting at 22 degrees. Okay, so we've got 22 degrees Celsius. Sketch the graph of the function over time interval. We've actually given that to you. Draw a chord between the points where h equals 1 and h equals 5. Now I was there. So there's my point h equals 1. There's my point h equals 5. And I'm going to draw a chord there. And you can actually use your equation to find the values at those points rather than trying to read it off the graph. But those are the points 119 and 527. Okay, now the gradient of that chord, we're going to just do down here because there isn't a whole lot of space up there. So we've got that m is y2 take y1 over x2 take x1. And that's going to be 27 minus 19 over 5 take 1. And we have 2 degrees Celsius per hour. Okay, or let's look, the gradient is just 2. But the average rate of change of temperature between h equals 1 and h equals 5. Okay, now with these, we want to interpret what the positive or the negative means. And because it's a positive 2, we can say that the temperature is increasing at an average rate of 2 degrees Celsius per hour. Okay, so temperature is, and we're looking for the word increasing, okay? Increasing at an average rate of 2 degrees Celsius per hour from h equals 1 to h equals 5. All right, so now we've dealt with average rates of change. But if we want to know how quickly something is changing at a particular point in time, we need to figure out a way to draw a straight line so that it can give us the gradient of that line at one point. Now you'll know from before that the minimum number of points you need to draw a straight line is 2. But in this case, you'll only have 1 point. You've got the rate of change at a particular point. And what we do then is we actually draw a tangent to the graph. Now you would have maybe heard the word tangent before. And what we say is that a tangent just touches the graph at a particular point, okay? I like to say it kisses the graph. It just touches it. And when we're doing it manually, what you're going to see is that everybody's tangent is going to look a little bit different, all right? So I want you to draw a tangent to this graph in example 4. Let's have a look. Okay, I'm going to draw my tangent, and I'm going to try and get it so that the line only just touches my graph. Okay, so that's what my tangent looks like. I'm expecting that yours is going to look slightly different. All right, and in order to find the gradient of that tangent, I'm going to need to find 2 points on my graph. Okay, so I'm going to see here, let's pick this point A. And it looks like it might be around about 6. Okay, so my point over there, my first point will be 6 and 8. And I'm going to take another point. Let's take this 4. And let's see where that ends up. And that looks like it's around about 14. Okay. So that point there is 14 and 4. All right. So I've got my 2 points, and I'm going to be saying that my gradient of my tangent, so m of t, is going to be y2 take y1 over x2 take x1. And I'm going to make this one x1, y1, x2, y2. And so I have 4 minus 8 over 14 minus 6. And that's going to be negative 4 over 8, which gives me negative 1/2. Okay, so it says, hence find the rate of change of weight W with respect to L when L equals 10 meters. So now, when L equals 10, that is where my tangent touches my graph. So my rate of change of weight with respect to length at that point will be the same as my gradient of my tangent. Okay, and again, we are interpreting the negative. So we're going to be saying that when L equals 10 meters, the weight is, and we negative is decreasing with respect to length at a rate of 1/2 kilogram per meter. All right.